Hello and welcome to the AI with Arun Show. We are on chapter 4 of the Beginner's Guide to AI AI in Action, Understanding Specific AI Fields. So, in this chapter, we'll look at AI in action, focusing on natural language processing for human language, computer vision for visual information, generative AI or GenAI for creating new content, and large language models, LLMs, which are powerful engines for text based AI. Natural language processing, or NLP, is a branch of AI dedicated to enabling computers to understand, interpret, generate, and interact with human language, both spoken and written. Since language is how humans primarily communicate, NLP aims to bridge the communication gap between us and the machines. NLP involves breaking down language, understanding grammar, discerning context, and extracting a meaning. This is complex because human language is often ambiguous and nuanced. Modern NLP heavily relies on machine learning and deep learning, particularly neural networks like transformer models, trained on massive amounts of text and speech data. For example, sophisticated spell checkers now use neural networks to distinguish between words that sound the same but have different meanings based on context. NLP powers many of the applications we use daily: chatbots and virtual assistants like Siri and Alexa, language translation tools like Google Translate, sentiment analysis, which determines if text expresses positive or negative sentiments, spell check and autocomplete features, text summarization tools, and information retrieval in search engines. Computer vision, or CV, is a field of AI that equips computers with the ability to see and interpret visual information from the world, much like the way humans do. It aims to enable machines to derive meaningful information from digital images, videos, and other visual inputs and then take actions or make recommendations. The process typically involves several stages. It starts with capturing visual data through cameras, then feature extraction identifies significant visual elements like edges and shapes. These features are converted into numerical representations. Subsequent steps can include object detection, finding specific objects, image classification, like categorizing an entire image, and a deeper image understanding, for example, interpreting relationships and context. Deep learning, especially convolutional neural networks, CNNs, is extremely effective for many computer vision tasks. Computer vision has a broad range of practical applications: facial recognition for security or unlocking phones, autonomous vehicles use CVs to perceive their surroundings. Medical image analysis assists doctors in analyzing scans to detect diseases. Manufacturing and quality control uses computer vision to inspect products, and it's crucial for augmented reality (AR) and virtual reality (VR). Generative AI, GenAI, represents a significant evolution, shifting AI from primarily analyzing existing data to AI that can create new, original content. This type of AI can generate text, images, audio, videos, and even computer code based on patterns learned from vast amounts of existing data. Generative AI typically involves training very large machine learning models, often called foundational models, which includes large language models for text or architectures like GANs and diffusion models for images on massive data sets. These models learn the underlying patterns and styles. Once trained, they can generate new examples that are novel and not just copies. For example, a model trained on thousands of cat images can generate a picture of a brand new, unique cat. Generative AI has exploded in popularity with applications like text generation, creating articles, emails, or code, and with tools like ChatGPT. Image generation, producing realistic images from text descriptions using systems like DALI. Music and audio generation, video generation and manipulation, synthetic data generation for training other AI models, and even drug discovery and material science. Large language models, or LLMs, are a type of foundational model and a specific class of deep learning algorithm that has become central to many of the recent AI advancements. especially in NLP and text based generative AI. These models are trained on truly massive quantities of text data, often encompassing a significant portion of the internet and books, sometimes trillions of words. The large in LLM refers not only to the vast training data sets, but also to the enormous size of the models themselves, often containing billions of internal settings called parameters. For example, OpenAI's GPT-3 has 175 billion parameters. A key architectural innovation is the transformer model. Transformers are neural networks adept at processing sequential data like text. They use self attention, allowing the model to weigh the importance of different words to understand context and nuances for more effectively. One remarkable characteristic of LLMs is their versatility. A single LLM can often perform a wide range of language tasks without specific retraining, sometimes referred to as zero shot or few shot learning. These tasks include text generation, question answering, summarization, translation, and engaging in conversations. Prominent examples include OpenAI's GPT series like ChatGPT, Google's Lambda and Palm, Anthropic's Claude, and Meta's Llama models. While LLMs generate fluent text, it's important to remember that they're sophisticated pattern matchers. Whether this constitutes true understanding in the human sense is debatable. Also, their power is a double edged sword, with potential for misuse in creating misinformation, alongside ethical questions about copyright training data. This brings us to the end of chapter 4. Thank you for watching the AI with Arun show and happy learning.